A man has just been shot dead. Inside the victim's jacket, a phone that has been silently recording the incident. You can hear two voices arguing, but you can't hear what they were arguing about. And as you lean and listen, off goes the gunshot. In cases like these, due to low speech intelligibility, barely audible low-level sounds, and audio disruption due to background noise, it would take hours, if not days, to identify and recognize the speakers, especially in cases which involve multiple audio evidence. With the emergence of CCTVs and mobile phones becoming the norm, cases like these are becoming increasingly common. So here's the demo for our production-ready dashboard. So this is the user interface. As you can see, first we clear the uploaded files first before we do anything else. And here is where we input the sound files. So let's pick one sound file and let's use it for our test case. We can also input multiple sound files. So let's try another one. Let's try another file. Both at once. Okay, so we press this button to see the attributes, and as you can see, it displays the timeline of the speakers. And so speaker 0 and speaker 1, as well as you can see the attributes down here, as well as the waveforms that separate the speakers. So let's try the other test case, and as you can see, it's the same thing here. And you can see that speaker 1 speaks until 7 and speaker 2 speaks until 7 to 8. And after this, we clear the uploaded files, and that is about it for the model deployment. Our solution, Vokal, is an AI-powered system that is able to accurately identify the number of speakers present, provide a timeline of active speech in the conversation, as well as display various predictions about the speaker's attributes. With Vokal, agencies are expected to decrease the time spent in identifying speakers in audio clips involving multiple parties through automation, reduce the error rate, and increase accuracy of speech identification through use of recent machine learning algorithms, and also reduce cost by using the Vokal system to minimize the workforce. Our target market is call centers and investigative agencies in the private sector. We also aim to receive funding from the government in exchange for our services, which can be used in multiple government agencies, namely police departments, emergency centers, and also intelligence agencies. There will be two versions of the website: a paid version for corporate structures with unlimited use and ability to access multiple files at once, and also a free version with restricted features for the general public, which can be monetized through advertising. For the AI model, we used PyTorch, scikit-learn, Celero VAD, and XVector by SpeechBrain. For the user interface, we used Streamlit for launching the web application, pip, PyDub to convert MP3 and MP4 to WAV, and OpenWeaver Candy for finding reusable diaries. We also used Slack for communication and Git for version control. For future implementation, if we were given more time, there are several key features we would aim to implement. Firstly, we'd like to add a database to store similar sounds. Next, we would add automatic location prediction based on similar sound clusters in the database. Then, for corporate structures, we would also like to add cloud storage to store transcripts and results. We'll also look into more partnerships in the private sector to generate more revenue. We also intend to increase the scope of our concept by using NLP to assess the content of dialogue and segment out targeted keywords and be offered as a subscription plan for investigative agencies. Finally, we expect to increase the scale of our product by going through extensive research and development through possible government funding. We are Team Gnosis. This has been our submission for challenge number 2. Thank you for your time.